lost and down into the light now. Lost and down into the light now. Lost and down into the light now. Lost and down into the light now.
Hello boys and girls of standard 11. Today I am going to start chapter number 2, relation and functions. So before entering into the chapter, first of all you must have the basic knowledge about set theory that you have come across in standard 6, 7, 8 classes. So first of all we will recapitulate all those points and see at the end of this video you must have the ability to do first 3 exercises of chapter number 1, that is sets. So both the chapter number 1 and 2 simultaneously will go ahead. Alright, so first of all we will discuss a little bit about sets. So I am not going to say anything detailed way, just I will say what are the points you come across in these many years. So first of all you studied about the definition of sets, that is collection of well-defined objects. Then you come across representation of sets, that is roster form, set builder form, tabular form, okay, even descriptive method. These are things we come across. There is a representation of sets. And then you come across different types of sets, equal sets, equivalent sets, single sets, infinite set, like that, so many things you come across. Then after that you come across the operations on sets, that is union of sets, intersection of sets, difference of sets, complement of a set. These all things you come across. And another thing you come across, what is the subsets of a set, subsets and proper subsets. So these are the things you come across in last 3 years, that is standard 6, 7, 8 classes, you come across all those things. But here just I will say about the subsets. After that we will go to standard 11 level part. So first of all we will discuss about subsets. Okay, see, I will consider an example. Let us say A is given 1, 2, 3. It's a subsets. What are the subsets of this? Subsets. First of all, I am taking all the elements at a stretch. That is the first subset 1, 2, 3. Now I am taking 2 elements at a time, like this 1, 2, 1, 3, 2, 3. So I have taken 2 elements at a time, all possibilities. Now we will go for 1 element at a time. One element at a time, then the last one is empty set. So these are the subsets of the set A, that is 1, 2, 3. If you count here, you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets are there. And you come across a result also based on that. If a set A is having n elements, number of subsets is equal to 2 to the power n. See here, this is having 3 elements. So 2 to the power 3, that is 8. See, if you count, you can see there are 8 subsets. This is the subsets. Now what is proper subsets? Except whatever be the set, except this, remaining all are proper subsets. So the number of proper subsets, if you want, it will be 2 to the power n minus 1. See, 8 minus 1, 7. 7 proper subsets are there. That means we can say if a set A is having n elements, then the number of subsets will be 2 to the power n, and number of proper subsets will be 2 to the power n minus 1. Now one more result here, actually that comes in standard 11. If you go for collection of all subsets, if I go for the collection of all subsets, this one is known as power set of the given set. This is the power set, that is collection of all subsets of a set is known as the power set. Okay, power set. So anyway, this is the thing you have to know, what is subsets and proper subsets. That is, this is how you studied in standard 8 itself. Just for namesake, once again I said. Now we will come across in standard 11 level, we will come across what is the we'll say product between two sets, that we'll say Cartesian product or we'll say cross product. So what is that I am going to say? This is new for you cross product. That is the product between two sets. See, let it be a set A is given 2, 3 and another set B is given, let it be X, Y, Z. Then how to find out the Cartesian product of these two sets? That is, we write like this: A cross B. You have to read it as A cross B. Don't read it as A into B. It is A cross B. So what is A cross B? A cross B will start from this. A is first, B is second. So from A we have to start first of all in the whole composition. That is with the 2 first of all I will write it 2x, then 2y, then 2z. See, 2x first with the 2, then 2y, 2z. All combination with the 2 I have to do it. With the 2 it is over. Now with the 3 I will do it. 3x, 3y, 3z. This is the cross product between the sets A and B, that is A cross B. See how many elements here? If you count, you can see 1, 2, 3, 4, 5, 6 elements. That will be same as here 2 elements, here 3 elements. 2 into 3, 6. That is same as here the total elements. So that is one property of cross product, that we can say like this: n of, that is cardinal number of n of A cross B. Cardinal number of A cross B is equal to n of A into n of B. See, n of A is, that is number of elements in A is 2. N of B means number of elements in B is 3. So 2 into 3, that is 6. That is same here, you can see 1, 2, 3, 4, 5, 6. Alright, so this is one property regarding the cross product, that is n of A cross B is equal to n of A into n of B. And one more thing, one more result we can see here: A is having 2 elements, B is having 3 elements, A cross B is having 6 elements. Naturally, A cross B will have how many subsets? That is subsets of A cross B. If you count the, if you want to make the subsets of A cross B, subsets of A cross B. It is number of subsets. Okay, number of subsets of A cross B is equal to 2 to the power. If you see here 2 to the power, here how it is coming? 6. 2 to the power 6. See 1, 2, 3, 4, 5, 6. 2 to the power 6. Okay, it will come 2 to the power 6 elements also. That is why. So we know the property: if A is having m elements, the number of subsets of A will be 2 to the power m. Same formula I applied. A cross B is having 6 elements, so the number of subsets will be 2 to the power 6. This can be written like this: 2 to the power 2 into 3. 2 into 3. In general, we can say that if A is having m elements and the set B is having n elements, then the number of subsets of A cross B, will be 2 to the power m into n. 2 to the power m into n. This is one result regarding the cross product. One result is n of A cross B is equal to n of A into n of B. Another thing is number of subsets of A cross B is equal to 2 to the power m into n, where m is the number of elements in the first set, n is the elements of the number of elements in the second set. This is also a result we will come across in cross product. And one more result, if you see A cross B, I have written this. If I go for B cross A, if I take, I have to start with the B first of all. If I want to write B cross A, if I go for B cross A, I will start with the B. From B I have to start, so x2, so it will come like that: x2, then x3, then with the y, y2, y3, then with the z, z2 and z3. Here if you see this A cross B and B cross A are totally different. So that is why we can say that A cross B is not equal to B cross A. A cross B is not equal to B cross A. So this is from here we can conclude that A cross B is not equal to B cross A. In general, we can say A cross B is not equal to B cross A. Okay, so but there will be some restrictions. Suppose the cross product, if you want, you can say cross product from A to A also, if you want, you can say it. In that case, we will get what A cross A is equal to A cross A. Even if we interchange also, it will be same thing. Means if you define a cross product on a set A, means its meaning is A cross A. A cross A, if you do it, this result in that case A cross A is equal to A cross A will come. But if it is A and B are two different sets, then A cross B is not equal to B cross A. So this is one result regarding this. Now if you see the elements of a cross product, these are like these elements. We write in bracket. It is always in pair format is coming, pair format. So this one has a particular name that we say it as ordered pair. We say it as ordered pair. Ordered pair means this only, it is an element of a cross product. It is an element of a cross product and its order is very important. See, for example, x2 is not same as 2x. x2 means x is the first component and 2 is the second component. So we cannot interchange these two. So that is why its order is very important. So order is very important. So that is why it is known as ordered pair. So we are going to say about some property regarding ordered pair. So ordered pair is coming by finding the cross product between the sets. Now what is the property of ordered pair? Suppose two ordered pairs are equal. Let it be one ordered pair xy is equal to another ordered pair ab. Suppose two ordered pairs are equal. If xy is equal to ab implies the first component, that is x is equal to a and y is equal to b. This is a result related to the ordered pair. Okay, if two ordered pairs are equal, their corresponding elements are equal. That means first components are equal, even second components are equal. So these are the things we required in the first exercise. So based on this, that is basically we will be dealing with the cross product. Cross product and in between we will come across few set related like a union, intersection, such type of things also we will come across. So that is the thing we are going to do it in the first exercise. Alright, now we will do few questions from the exercise. So remember that along with this exercise simultaneously you have to do first three exercises of sets. There won't be any separate class for sets. Okay. So first three exercises you are supposed to do along with this exercise. So exercise 2.1, first of all we will do question number 2, second one. The question is, we have to solve, it is given an ordered pair 2x plus y comma x minus y. This one ordered pair is equal to another ordered pair. We have to find out, we have to solve means we have to find the values of x and y. So here, which property is applicable? Ordered pair. If two ordered pairs are equal, you know that what? Their corresponding elements are equal. That means 2x plus y. This means we can say 2x plus y is equal to 8. First components are equal. And x minus y is equal to 3. X minus y is equal to 3. Now solve just simultaneously. Just solve simultaneously. If we add, this cancel. Here 3x. 3x is equal to 11. X is equal to 11 by 3. We got the value of x. Now this x value substitute any one of the equation, you will get the value of y. So I am substituting here. Y is equal to x minus 3. Here I am putting 11 by 3 minus 3. Take LCM. 11 minus 9, that is 2 by 3. So simple question, only we use the property. If two ordered pairs are equal, then their corresponding elements are equal. Based on that, we solve it. So this type of few questions you will see in the exercise. Okay, all of you copy down the work. So means a 2 marks question they can ask based on this. This is question number 2, second part. Now we will go to another sum. Question number 3 we will do it. Question number 3. The question is given, if the ordered pairs a comma minus 1 and 5 comma b. If these two ordered pairs belongs to, they are telling this is belongs to means I can write like belongs to the set xy such that y is equal to 2x minus 3. If these two ordered pairs are belongs to that particular set, question is we have to find the value of a and b. We have to find the values of a and b. So if these points, this ordered pairs belongs to this, so what you can do is, there is one linear relation is given y is equal to 2x minus 3. In this we can substitute this. This here x is a, y is minus 1. So minus 1 is equal to 2a minus 3. From here 2a is equal to 2, a is equal to 1. Alright, this is the value of a. Now for getting b, again b also we can substitute here. X is 5, y is b. So I am putting there y is equal to 2x minus 3. There I am putting y is b. 2 into 5 minus 3, 10 minus 3 is 7. This is the values of a and b. Only thing is the way question they give, you must be able to understand what is it. Otherwise, it's all very simple questions. So this is question number 3. All of you note down. After that only you proceed to the next part. You can pause your video and note down. After that go to the next part. Now we will do question number 4. Question number 4. Here the set P is given 7, 8. Q is given 5, 4, 2. We have to find out P cross Q. P cross Q and Q cross P, I will show only one part. P cross Q I am going to find out. P cross Q. So that is cross product. P cross Q means you are starting with them from P. So first of all with the 7, all combinations. 7, 5, 7, 4, 7, 2. With the 7 all combination you have to take it. With the 7 all combinations. Alright. And then we have to go with 8. 8, 5, 8, 4 and 8, 2. This is the cross product. With 8 also all combinations. Alright, with 8 also all combinations. This is only the cross product P cross Q. If they ask me Q cross P, from Q you have to start first. Alright, simple question. There is a cross product. Already I told. What is that? So just copy down this and then next question. All questions are all small questions here. Question number 4. Next we will do question number 13. We will do question number 13. Here the set A is given minus 1, 0, 1, 2, 3. A is given this. Write the subsets S of A cross L. We need S. It is a subset of A cross L. Write the subset S. This is the symbol of subset. Subsets S of A cross A such that the second component of the elements of S is 0. Second component of this means if you go for this A cross A it will be ordered pair. In this ordered pair they are telling the second component of the element must be 0. This must be 0. Here some element must be there. The second component must be 0. Only we need such a type of elements. We don't want to write the subsets of S of A cross A. So we don't want to write A cross A. If you go for A cross A, there will be so many elements. 1, 2, 3, 4, 5. 5 into 5, 25 elements will come. 25 elements. We don't have to write that. We need only the elements of S. But it is from A cross A. So actually it will be A cross A means this cross with it. Its meaning is minus 1, 0, 1, 2, 3. It's to cross with the same thing. Minus 1, 0, 1, 2, 3. This is the meaning of A cross A. A cross A from A to A is. But we need only the elements of S. in that second component is 0. Second component is 0, such type of elements only we need. So we'll see with the minus 1. Minus 1 is the first element, but the second component is not 0. But minus 1, 0. Minus 1, 0, that is possible. Second component is 0. So we don't want the first one. Again, minus 1, if you go for any more combination, no case it is 0. Now with the 0. With the 0, 0 minus 1, no use, because second component we need 0. So but 0, 0 we can write 0, 0. Now with the 1, 0. No other elements with the 1. With the 2, 2, 0. With the 3, 3, 0. So these are the elements of S. S is naturally S is subset of A cross A. Since A cross A will be having 25 elements. But here only how many elements? 1, 2, 3, 4, 5. Only 5 elements. So these are the elements of S. It's the second component is 0. See, all cases second component is 0. So we need only the selected elements. Selected elements. That is actually it is the subset of the A cross A. We are going to discuss detailed way about this. We are going to discuss in the second video. Okay, in that case, that time we will discuss about a term, relation, that time we will be discussing about this type of situation, that is the subset of cross product. This is a subset of cross product. Alright, this is question number 13. We only selected few elements of the cross product. So this is question number, it was 11, and that was question number 13. Now we will do question number 22. Question number 22. Here A is given, set of for X such that X belongs to W. W means, I think all of you know, it is whole numbers. Here the set A is given in set builder form, and B is also given in set builder form. X such that X belongs to N, 1 less than X less than 5. And C, another set C is given. This is C is given. It is in, you can see it is given in what is called roster form or tabular form. Okay, that is C is given. We have to find out A cross B intersection C. That is the first part. And one more part is there. Two parts we will do it. First of all, A cross B intersection C. We will go for this part first of all. So for that, first of all, I need the elements of A and B in tabular form. So here is where I am writing directly. What is it? Its meaning is all the whole numbers less than 2. W stands for whole numbers. All whole numbers less than 2 is 0, 1. 2 we cannot include. Less than 2. Clearly, strictly less than 2. Okay, that is A is 0, 1. And B is all the natural number between 1 to 5. 1 to 5. So from this we can write B. I can write B is equal to 2, 3, 4. This is the elements of B. Now, I need B intersection C, so I am going to write directly here. A cross B intersection C is equal to A is already been on 0, 1 cross B intersection C. If you see B and C intersection means the common elements. Here common element is only 3. This is B intersection C. B intersection C is only 3. Now we have to go for the cross product. 0, 3 with 1, 1, 3. This is the first part. A cross B intersection C. And one more part is there in this question. We have to find out. Second part, it was A cross B union C. So first of all, A is 0, 1 cross B union C. B union C. It's a union. Union means all the elements together. So if you go for the union, it is coming 2, 3, 4, 5. 2, 3, 4, 5. This is B union C. 2, 3, 4, 5. Now you have to write down all the elements here. 2, here 4 elements. 2 into 4, 8 elements will come all together. First of all with the 0, 0, 2, 0, 3, 0, 4, 0, 5. With 0 it is over, now with 1. 1, 2, 1, 3, 1, 4, and then 1, 5. These are the elements of A cross B union C. So part by part we find out and just find to go for the cross product. This is this question. Okay, pause your video, copy down all the notes, all these question. Now one more sum we will do it. One more sum we will do it. After that we will stop today's class. That is question number 24. The set P is given 1, 2. We have to find out the P cross P. We have to do it. This is the question. So what we will do, first of all, P cross P we will do it. Okay, its meaning is 1, 2 cross 1, 2 cross 1. P cross P. So I am going for these two cross product first of all. That is 1, 1, 1, 2. With the 1 overtaken, now with the 2, 2, 1, 2, 2. Cross 1. First of all, I went for the cross product of these two and I will go for the cross product of that. So this 1. So 1, 1, 1. You can see it become, okay, 3 elements coming together. Now 1, 1, 2. Now with 1, 2. 1, 2, 1. 1, 2, 2. Now with 2, 1. 2, 1, 1. 2, 1, 2. The 2, 1 it is over. Now with the 2, 2. 2, 2, 1. And 2, 2, 2. So here we went for P cross P. So these are the elements of this set. So we will stop here.